Thank you for joining us today for an overview of cutting technologies for robotics, engineering, and STEM. My name is Ronnie Tatum and I'm the service manager here at Teaching Systems. I will be walking you through a demonstration of designing a robot gripper part, processing it, and cutting it on the Wazer desktop Waterjet system. Robotics and engineering programs have a lot of cutting systems to choose from. Some of them are limited to the materials they can cut, others have a steep learning curve, and some of them just require a big footprint in a shop. The Wazer desktop Waterjet system takes all the guesswork out of processing and cutting a CAD file with the Waterjet system. Materials like aluminum, titanium, and even plastics, glass, and stone are easily cut. It's an easy product with a short learning curve. You can be up and running within minutes after initial setup. To get started, let's take a quick overview tour of the Wazer Waterjet system. There are two main components. The main unit here, which does the main cutting. Below it, or sometimes to the side of it, you have the pump. A Waterjet system uses a high pressure stream of water mixed with a crushed rock abrasive to produce a stream of water that can cut almost any material. Again, special materials like aluminum, titanium, and plastic, stone, and glass are easily cut on the Waterjet system. The main unit itself has a few key components. First, we have the nozzle, which mixes the abrasive with the water to create the cutting stream. We have the cut bed, which is where you fasten your material to for the cutting. We have the abrasive drawer, which is where you load your fresh abrasive. And we have the abrasive buckets, which are used to easily empty the spin abrasive from the system. There's very little maintenance with the Waterjet system. The control panel is easily accessible on top. This is where you load your cut file and start your cut process. It also has some safety features involved as well. The system will not cut or will stop cutting if the door is opened and not closed. It also has special water detection leak alarm, which will go off if it detects a leak to let you know that there's a problem. It's such a simple machine that even a makerspace or a clean fab shop can accommodate it. So now let's go ahead and go through the demonstration of designing the robot part, processing it in the Wazer WAM software, and cutting it on the machine.
For today's demonstration, we'll be using the Vectric VCarve Pro program, a simple 2D CAD program to design our robotic connecting rod and export it as an SVG file for the Wazer WAM program. We're going to begin by creating a new file and setting our job size to the size of the material that we'll have in the machine. We'll be using a piece of aluminum that is roughly 150 millimeters wide, 50 millimeters high, and 3 millimeters thick. Our datum position is irrelevant for our purposes today, and our units are set to millimeters. We'll click OK. We're going to start by drawing the inner circle of one end of our connecting rod. So under Create Vectors menu, we're going to choose our Draw Circle tool. We're going to come out on our page, and we're going to click and drag our circle, and we're going to give it a diameter of 3.2 millimeters, and click Apply. Now we're going to draw another circle by using the inner part of our first circle to snap to, and we're going to give it a diameter of 8 millimeters. Click Apply and Close. Now we need to draw the length of our connecting rod, which we know is 36 millimeters. So we're going to use our line tool to draw a reference line to base it off of. We're going to snap to the inner circle. We're going to draw our line. You'll see that the cursor gives you the length of the line as you draw it. It'll also snap horizontally. So we'll draw it to 36 millimeters and we'll click to end it. We'll click Close. Now we can draw our other two circles on the other end. So we're going to click our circle tool again, snap to the end of our line, click and drag, give it a diameter of 3.2 millimeters, click Apply, snap to the end of the line again, draw our second circle, give it a diameter of 8 millimeters, and click Apply. Now we can close our circle menu. Now we need to create the body of our connecting rod between our two circles, and we're going to be using our first reference line to do that. we're going to use our offset tool under offset and layout to offset on either side of this one line and create two new lines. So we're going to offset in both directions. We know our body is 4.8 millimeters thick, so we're going to do a distance of 2.4, so each line is equally the same distance, and we're going to delete our original reference line that we're using. When we click the offset button, you'll see that our two lines are created and our reference line is gone. Now we'll click close, and we're going to need to merge all our geometry together into the one shape of the connecting rod. To do this, VCarve has a very simple tool called the vector trim. It looks like a little pair of scissors under the Edit Objects menu. We're going to click on our scissors. When we place our scissors over a piece of geometry, you'll see that they open up. This tells us that we can cut that geometry and trim it out. So I'm going to trim out that inner piece there. I'm going to trim out the two tails there. I'm going to do the same thing on the other end. Trim out the two tails. And that leaves us our final shape of our connecting rod. We can close our vector trim, and now we're ready to export it to an SVG file. We're going to drag a box around our entire connecting rod so that it's highlighted. We're going to go to File, down to Export. We're going to choose SVG, and we're going to give it a name. Now we're ready to import it into the Wazer WAM program and process it for cutting on the machine. The last step of the process is to use the Wazer WAM program to import our part and generate the G-code file to run on the machine. So first step, we're going to import our file, choose our connecting rod, and it will bring it in onto the representation of the cut table. We can drag our part anywhere on the cut table that we want. We can also choose additional copies of the part if we need more than one. And we can also import additional files and other parts to cut along with these. The next step is to change our scale and position if needed. We can rotate the part if we want it to be in a different orientation. We can also change the physical dimension placement it is on the cut bed. We can adjust the scale, so if we need a quarter scale model of this part, we could do that easily. The next step is to choose the material that we're going to be using. We're going to be doing aluminum 6061 at an 1/8 inch thick. You'll see that there is a library of a bunch of materials already set up. You can also add and edit materials as you need to. The next step is to choose our cut path, either outside, center line, or inside. This will help accommodate for dimensional accuracy to be sure that the cut line is positioned so that our part is the correct size. Tabs and leads are used to hold the cutout pieces in place until the end of the cut, and leads are used to establish a pierce point away from the part so that the edge of our part will not be gouged. The last step is to choose our cut quality, coarse, medium, or fine, which is basically a runtime versus cut quality versus edge quality. So if we're not concerned with edge quality and we want a fast cut time, we can choose coarse. If we need a cleaner cut and we're not concerned with the time, we can choose fine. The last step is to give it a name. This will be the name of the actual G-code file, and then generate the job file. Now we can open up the folder that the file was downloaded to. The easiest thing to do is right click and say send to our Wazer memory card. Now the file is copied to our Wazer memory card, and we can take the card to the machine and begin the cut process. Insert the Wazer memory card into the machine. Power on the machine and wait for the main menu. Select Cut File, then the G-code file, and prepare machine to cut this file. Follow the steps to lift the nozzle for the machine to home. Loosen the nozzle lock knob. Raise the nozzle to its highest point and tighten the lock knob. A status screen will appear summarizing the part to be cut. Next, the abrasive drawer needs to be filled. Open the abrasive drawer on the left side of the Wazer. Use a scoop or pitcher, fill the abrasive to the top of the filter screens. Close the drawer completely. The machine will remind you to ensure the water supply is on. And then instruct you to fasten the material to the cut bed. Place the material on the cut bed at the location you want to cut. Use the supplied mounting screws and washers to fasten the material to the cut bed. Gently try to move the material to ensure it is secure to the cut bed. Next, you will need to set the nozzle height on the material. Remove the nozzle height gauge and place it under the nozzle. Loosen the nozzle lock knob and lower the nozzle to touch the gauge. Tighten the nozzle lock knob. Replace the gauge back on top of the nozzle. And then choose Cut Material. You will also have an option to check cut extents for placement, as well as perform a dry run. Last, close the door. Then press the Start button to begin the cutting.
Now that you've seen a demonstration of the Wazer desktop Waterjet system, I'm sure you can see how easy it is to go from design to processing to actual cutting. Although we used a simple CAD program like VCarve, any CAD program will work. All you need is a DXF or SVG file to process in the Wazer WAM program. Even if your robotics and engineering programs already have other cutting technologies in place, the addition of the Wazer system can be very beneficial, especially with hard-to-cut materials like aluminum, titanium, and brass. It also works seamlessly in a fab shop or STEM makerspace. And whether you have experience with other cutting technologies or not, or you're a first-time user, it's simple and easy to learn to use the Wazer Waterjet system. To request a sample part or for more information, please contact us at Teaching Systems. Thank you for watching.
The Wazer starter bundle right now is $99.99. A Waterjet for under $10,000 and has an operating cost of 16 cents a minute is the most economical way to cut difficult materials like aluminum and titanium, as well as glass, plastics, and stone. The bundle includes everything needed to get up and running in minutes after installation and cut hundreds of parts. The bundle includes the main unit, the pump, a floor stand, 3 additional cut beds, an additional nozzle, water alarm sensors, accessory kit, plumbing kit, and additional small spare parts. Professional installation and training are available for additional cost and will give one-to-one hands-on instruction with the trainer to ensure you are ready to go. Sample parts are available by contacting us at Teaching Systems, and we can help answer any questions you have. Once again, thank you for watching our demonstration of cutting technologies for robotics, engineering, and STEM using the Wazer desktop Waterjet system.